In this video, we are going to talk about linear equations eventually. We are going to be talking about just kind of variable notation and equation and expression and kind of talk about some terminology kinds of things. So first main thing is what is an equation? And people confuse equations and expressions all the time. So it's a mathematical statement with two equal expressions. Okay, key is equal, which means you have to have an equal sign in there. If you don't have an equal sign, then there's nothing to solve and it's not an equation. Okay, so an expression is basically this side. So if you drop the equal sign on the other side, that's a mathematical expression, and that's an expression, right? When you put the two together, you have an expression equaling an expression. You're supposed to be it's supposed to be a true statement. If there's a variable associated with it, then you're trying to fill the gap for that variable to make it a true statement. Okay, and so that's a little bit on a different video, but basically every single one of these things, if it says this is equal to this, then it's supposed to be a true statement. So 3 times 8 is equal to 24. So that is true. Okay, so here you have 12 minus 3 is supposed to be equal to 2 plus 7. Again, that side is an expression. That side is an expression. When you put the two together equal to each other, now you have an equation. So this side, 12 minus 3 is 9. This side is 9, and they are equal to each other. So that is also a true statement. Okay. So if you have a variable, you're trying to fill the gap to make sure that that value makes the statement true. So what would x have to be to equal the other side? Well, those two values add up to 11. So x would need to equal 11. So if you put 11 here, it'd be equal to 3 plus 8. Right? And then kind of so on and so on. So if you have something like this, 18 divided by 3 is 6. So n would equal 6. And then over here, we have 3 times 4 minus 5. So we'll just do some order of operations to figure out what y would equal. So that's going to be a 12 minus a 5, which is 7. All right, so that's what y equals. So what are terms? So you're going to get a little bit more complicated looking equations and expressions. So what are terms? Here's kind of the fancy version of it, and then we'll do an example. But it is a single quantity or product or quotient. So a quotient is just a division piece. Okay, so for example, if you just have the number 3, that's considered a term. If you have a 3x, that's considered a term. If you have a 3xy, that's considered a term. If you have 3x divided by y, that's considered a term. Every one of these is a separate term. Okay, so what separates terms are plus and minus signs. So if you have a plus or a minus, that's separating your terms. So that's a term and that's a term. So you have two terms. Okay, so multiplication and division does not separate terms out. It's adding and subtracting that separates it. So you got a 1 plus sign, 2, 3, and that actually is going to be, this whole chunk is going to be represented as a term. All right, so if you distribute it in, then you get more terms, but this is a term, this is a term, this is a term, and then because it's multiplication, that's a term. Okay, kind of overrides that individual plus in here. Okay, so that gets you 4 terms. And then last one here. So you have 1, 2 terms. Okay. So then what is within these terms, you have some different names for some stuff. So we have a constant. So a constant is a constant is a term with no variable. So example is just a number. Okay, so back on the last page, we had a couple of them that's a constant, that's a constant. And that would be it out of these chunks, because if you have a variable on it, it's not a constant, because if the variable is replaced with a number, that value is always 5. That value is 3 times whatever you put in for it, so it's not, doesn't stay constant. This value never changes. It's just 5. No matter what x is, doesn't have any effect on the 5. Okay. So that is a constant. So it's a term that doesn't have a variable. And then what is a variable term? Term with a variable. So 3x would be a term with a variable. And then within that, this 3x, you have a piece that's called a coefficient. It is the number in front of a variable. So for example, if you have 2x, that 2 is the coefficient. It's what is multiplied to the x, okay? Now, what if you just had an x? Well, there's always a value in front of it, even though there isn't something sitting there. It is an invisible 1. But there's always something. So there's always a value in front of it. So that would be a 1 would be sitting here, okay? All right, so what is the coefficient in each term? Coefficient is the 2. And here, the coefficient is the whole thing of -3. And the coefficient here, a better way to probably write this, I would write it different every single time, is I would write it as 2/3 b. That's the same thing, because it's 2/3 times b as opposed to 2 times b divided by 3. And that is your coefficient. Just makes it easier to see if you kind of break up the fraction off of the variable. So, all right. And then this is, we're going to try to put some stuff into some words. So the language on this is a couple different ways to write it, but you know, other than just saying x minus 7 equals 4, then a little bit of a fancier way to write this is maybe something like the difference. And since it's subtraction, the order matters. So you have to say the difference between a number, because that's the first value, a number and 7 is 4. Okay, so that's kind of a fancy version of that. And then over here, you could write something like, since it's a division, you know, obviously x divided by 5 equals 3. There is 3. Or a fancy version of that is the quotient So the fancy again version of this is the quotient of a number. Again, kind of order matters on division. The quotient of a number and 5 is 3. All right, and then this one, a little bit fancier, is we got to talk about kind of order of operations. So we are going to have the sum of a number and 3. Sum of a number and 3 times 2 is 14. Okay, so that does this first, because order operations would do the sum of these two first, and then whatever that is times 2 is 14. All right, and then we're going to go the other direction. So it says the sum of 12, 23, and a third number. So the sum of 12, 23, and a third number is 52. Is 52. And then when a number is subtracted from 45, not subtracted by 45, that's different. So if it's subtracted from 45, we're looking at 45 minus a number, and the result is 17. Okay, so make sure you read the wording on that. If it did say subtracted by 45, then it would be x minus 45, but it's subtracted from. All right, a little bit more. So simplifying. Simplifying is combining like terms. Okay, so let me just throw that up here. So for simplifying, we are combining like terms. So we're putting variables together with variables, we're putting numbers together with numbers, constants with constants. Okay, so here we're looking at, we have a 5a and a 2a that can add together. So when you add them together, you're adding the 5 and the 2. The a is what makes them match, like makes them like terms. So you're still sitting with a. And then there's another value. Let me put a 1 in front of that. But basically we have, if we just kind of work straight across, we got a 5a plus a 2a and then minus 1a. So we got 7a minus a 1a. 7a minus a 1a gets you a 6a. Okay. And then over here, we got, let's see, we got some like terms. Let me try to organize this a little bit. We got 3 separate kinds of like terms. We're not solving. I know there's an equal sign on here, but we're not trying to solve anything. We're cleaning it up basically. So we have a 3x and a negative 2x that need to go together. So you got a 3x minus 2x. We have a 5y and a 1y. So we'll be adding those two together. They're both positive. So 5y plus 1y. So then that part equals a 1x or just an x. This is 5y plus 1y, gets you a 6y. So if we kind of, and that 8 does everything to combine with. Okay, so the best we can do to kind of clean this up is we'll put the 3x and the negative 2x together and get x. We'll put the 5y and the 1y together, and that'll get us a plus 6y. And then we'll just tack that plus 8 onto the end, and then it equals 12. And that's the best that we can do as far as simplifying. Okay, just kind of clean it up. Put together what we can. All right, and then the last thing is we're going to do a little bit of distribution. Distribution is taking that 3 and it is multiplying. So you're going to multiply that 3 to both terms. So 3 times 5x is 15x minus 3 times 2 is 6. Okay, we didn't change the sign. That can happen, but not on this one. So signs stay the same. The values just get tripled. So the 5 turns into 15 and the 2 turns into 6. Here you're distributing a negative and a 7. So it's going to switch all of their signs and it's going to multiply everything by 7. So this is going to become a negative 7x. This one's going to become a negative 7y. And then this one's a negative times a negative, which is a positive. 7 times 3 is 21z. All right, and then the last one is just a negative sign distributed in. Another way to think of this is actually like a negative 1 being distributed in. So it's not going to change the numbers, it's just going to change the signs on those numbers. So when you do the negative 1 times the negative 3, that makes it a positive 3. And the x is still there. And then when you distribute it to the 4, it was a positive 4, but it's going to become a negative 4. Okay, so this is just kind of a stepping stone to eventually solving equations. So simplifying, getting rid of parentheses, doing distribution, combining like terms, those are all kind of pre-steps to actually doing the solving process that's coming up next. All right, thanks.